Hello, and this time I'm looking at a couple of examples of questions, exam style questions, where it's in a context. That's why it's sort of modelling, but the equations involve trigonometric functions. So we've got to use some trigonometry that I've done in some previous videos. So trigonometric identities like the angle, double angle, and the addition identities. Maybe the simplifying a cos x b sine x into sine of something plus something, that kind of thing, in order to get it into a state where we can say things about the context from the equation and from the trigonometry itself, and how we can use what we know about trigonometry to therefore know things about the situation here. So anyway, let's get started. Read the question. The price P of a stock in pounds during a 9-hour trading window can be modelled like this, and we've got the price being some constant plus some trigonometric function here, the sine of some algebra. T is the time in hours after it opens, and angles are all in radians, so just make sure our calculator's in radians as well. State the beginning and end price of the stock. Well, actually, this is really straightforward. At the beginning, T equals 0, so if you just substitute that in, that will disappear, 0.7 times 0, and you can then just work out what that is by just typing in the calculator, no problem. And for the end price, well, that will be after 9 hours, so we can just put T equals 9 in, and of course that won't be 0 anymore, that will be whatever 0.7 times 9 is, but again, just type it all into the calculator and write down the value you get with your calculator in radians. Make sure you have turned it into the right unit, otherwise you'll get the wrong answer. And that's it, there's nothing more to do there. I'm not going to do it, it's just going to take time on the video typing it into the calculator. I'll let you do that. Calculate the maximum price of the stock and the time when it occurs. Well, we only need to find one of these things, and then we can find the other. And it's much easier to find the price from the time than it is to rearrange and get the time from the price. So let's see if we can get the time. Now, this is a sine function, so we know what they look like. Now, I appreciate it's been moved around and, mucked about and all that kind of thing, but it looks something like this. It might be squashed in, it might not start in the right place, etc., etc. But what we know is that what we want to do is we want to get that value here to be 1. That's the biggest that can be. Although it then gets timesed up, it doesn't matter. Sine of something, the biggest that can be is 1. So that means that the maximum will occur. Sorry, that's 0.7 minus 3 equals 1. Okay, it's the biggest that sine can be. Well, let's think about that. It won't happen, it won't be when t is pi over 2, because it's been, this is transformed about. We've got the normal sine and it's been shrunk in. Actually, no, stretched out, because timesing would normally shrink it in, but it's a 0 point, so it's been sort of stretched out a bit and then shifted 3 over. So the t value doesn't line up with pi over 2 anymore, 90 degrees for that maximum. But this thing does, because if it was just sine of x equals 1, then we know that the value of x that gives 1 is 90 degrees, or pi over 2. So in order to get this, we need 0.7 t minus 3 to equal pi over 2. And we can add the 3 to move that across, and we can divide by the 0.7. So we're dividing everything by 0.7. We'll just write it like this, a bit lazy. But in fact, no, let's not write it like that, just because I can't cope with fractions and fractions. 2 times 0.7 is 1.4, and a 0.7 there. So now we can just type that into our calculator, and we'll just get a value. So we've got, what's this, pi over 1.4 plus 3 over 0.7, which gives us 6 and just over half hours. If it doesn't say, it just says the time it occurs. Now it might want it in like hours and minutes rather than in just in hours and decimal. So you have got the degrees, minutes and seconds button, which also works for hours, minutes and seconds. So this is 6 hours, 31 minutes and 46.59 seconds if you need it in that form. Okay, so we've got the answer there. Let's have it, press it again, let's go back into this. 6.5297. 6.5297. If we know the time, we can now substitute this back in over here, and just work that out, that whole equation out, and get the price and that will give us the maximum price. So that's nice and easy. A day trader wants to sell the stock when it first shows a profit of 40 pence above the day's starting price. At what time should the trader sell the stock? Okay, so that shouldn't be too bad. Let's give ourselves a bit of space. We know a price and we want to know a time, so we're just going to use the equation. 0.4 for the price, that's in pounds, equals 17.4 plus 2 sine of 0.7t minus 3. Okay, well, we can rearrange this easily enough. We'll just take the 17.4 away and get minus 17 equals 2 sine, etc. Divide by the 2 and get rid of that. We can inverse sine in order to get 0.7t minus 3 equals an amount. And then we can just rearrange it for t. Of course, you will get several answers because of that sign. You'll get several answers, and probably just the straight off the calculator answer that you get will be the right one. But it might be worth just doing your cast diagram just to check what the other correct answers are in case one comes out smaller than the other. I'd be surprised, but you never know. Always worth checking. So that should be, again, now we've got it in that form. It's just a case of solving it and doing the cast diagram. If you're not happy about how to do cast diagrams, I'm sure I've done another video on it. If I haven't, just let me know and I will go through how to deal with cast diagrams and how to solve this. But it's just once you've got it in this form, you can pretty much do it. If you've got this calculator, then of course you can check your answer as well by typing it all in. Unless it's so complicated that it can't do it by its numerical methods. I don't know, but I've always assumed it does Newton-Raphson. If you don't know what that is, don't worry about it. I've got to call it X because I don't have a T. And then I'm just going to go Shift Solve. That's not the answer. That's just where it's going to start looking. And it will take a while. Oh, interesting. It can't solve it. Interesting. Let's try X as 10 instead. Oh, well, no, hang on, that's silly because we know it's between 0 and 9. So let's start in the middle and say 4.5 and see how it gets on. Oh, there you go. So it's too complicated for that shift solve to work. Perhaps, though, if you rearrange it and get it closer into sine of something like this, it might be able to deal with it after that. I have just noticed I'm in degrees, so it's entirely plausible. That was a bit silly, wasn't it? Put it in radians, and now try it. I still can't do it. So you're on your own there. Move that across, divide that, inverse sine it, and then solve your answer for t. Right, let's move on to my second example and see if this is any different. Oh, it is different because we know we're going to have to do the sine, cos and sine being simplified. So okay, and it's nice because they're scaffolding it for us. They've just asked us to do that, and then presumably that will help us. This thing will be similar to this, I would have thought. But anyway, oh no, actually it is here, isn't it? Because we've got 65 cos and 20 there, so it's there. It's just they've put an extra constant and 0.2 in. So we're going to use this result to then mush it here. They don't have to give you this prompt, in which case it will be very difficult to spot that that's what we're doing here, that you've got a cos of something plus sine of something, and you can do that. Might be tricky, but anyway, they've given us the clue, so we may as well use it. So expanding this, r cos theta plus alpha is r cos theta cos alpha minus r sine theta sine alpha. Okay, and what we want is 65 cos alpha, theta even, and minus 20 sine theta, which tells us that, and we'll do it up here, r cos alpha equals 65, and r sine alpha equals 20. Okay, I have got another video all about how you do these and how you sort of set it up. So if you need more examples of those, then you can find that one out, simplifying a cos x plus b sine x. Okay, so now we can work these out. If we do this equation divided by this one, the r's will cancel, and we'll get that tan of alpha equals 20 over 65. We're in radians because it's told us pi over 2, so make sure our calculator's in radians. And yes, we're in radians, that's good. Shift tan of 20 over 65 is giving us 0.2985. 0.2985. Whoops, that's not a 5. There we go. That's a 9. Apologies for my terrible handwriting. And then to get the r, now we, in a previous video, we learned don't just substitute that in, because the calculator won't necessarily recognize that it's an exact value. So instead, we're going to square this and add them together. So have to do the same for these numbers as well. And when we do that, we can factorize out the r squared, and we end up with r squared times cos squared plus sine squared, and we know that cos squared plus sine squared is 1. So we can say r squared equals 65 squared plus 20 squared. And then we can just work that out. So 65 squared plus 20 squared equals 4625. Any chance that that's square roots? No. But anyway, at least we have it in a simpler form, 5 root 185. 5 root 185. Okay, so here we have our two answers. We have, shouldn't have written that, alpha equals that, and again, we've done that wrong, so we're saying r squared there, r equals this. So we can now rewrite it in this form, and we can say, so give the value of alpha, 4 decimal places. I didn't actually read that, I just picked a nice place where the rounding was okay. So we can rewrite it. It just wants you to, no, it does say express in the form, so it wants it to rewrite it. So it's going to be 5 root 185. The fact that it doesn't say give r to a certain degree of accuracy is because we can do it exactly, so please do. Okay, so r cos of theta plus 0.2985. Right, that's part A sorted. City wants to build a large rectangular wheel as a tourist attraction. The height of a tourist on the circular wheel is modelled by this equation. Now, as we said, this is very similar to what we have here. The only difference is that theta equals 0.2t. At no point did theta's value come into this at all, so I think we are well within our rights just to rewrite this and substitute in 0.2t for theta. So we can say that h equals 70 minus, and this whole thing is this whole thing, so minus 5 root 185 cos of 0.2t plus 0.2985. Right. H is the height, t is the number of minutes after boarding, and the angles are in radians. That's fine. Find the maximum height of the wheel. Okay, well, the maximum height of the wheel is going to be when this thing is a maximum. Okay, because cos of anything is always between 1 and minus 1. No matter what this garbled stuff is, the best we can do for cos of something is 1, which means that this would all just disappear, and so the maximum height, h max, is going to be 70 minus 5 root 185. Oh, wait, no, I'm being crazy here, because we've got this minus sign, and this can be 1, but it could also be minus 1. So actually, when this is minus 1, that's going to change that sign. H max is going to be 70 plus 5 root 185. That was close. I would have lost some marks in the exam if I hadn't spotted that. Of course, yes, because it can be 1 or minus 1, and actually that's going to be bigger, obviously adding that on. The time for one complete revolution in part C. Okay, well, we can use this again, because if we think about what the cos is looking like, we've got the cos sign going here, and one whole period of the cos graph is representing one complete revolution. So we said that when cos was minus 1, we're at the maximum height at this point on the cos graph, and so it will happen next when we're here. So what we need is we need those two values, and then we can just subtract to get the time in between. So that means that if this thing has to equal -1, that will happen when this angle equals, what would that be? That's going to be pi, because that's halfway through the cos. So at 0.2t plus 0.2985 equals pi, that's going to be our sort of starting point, and then 0.2t plus 0.2985 equals 3 pi, and you're going to work out what the t is for this. Just take away, divide, and those two values of t, you're going to find the difference between them, and that will be the time for one complete revolution. Again, I'll let you do the actual number crunching. And then finally, part D, the number of minutes the tourist will be over 100 meters above the ground in each revolution. Right, okay, well, yes, that should be okay as well, because we've got it written in this form. So we'll just get rid of all this, just to give us a bit of space on the page, on the screen. What we want is the time it takes, the time when they are 100 meters above the ground. So we're going to say 100 equals 70 minus 5 root 185 cos of 0.2t plus 0.2985. And then it's just a simple case of solving for t. So what you'll want to do is add that to that side and take that away. So all of this, let's just do change of sign. So that's minus, that's plus. That's a lot easier. Now we can add the 70 to both sides and say minus 30 equals all of this. Divide by the 5 root 185, inverse cos, take that away, divide by that, work out your value of t, and of course there'll be two values of t. You'll need to do your cast diagram. All students talk crap, and as this cos is giving us a negative answer, then it will be in, presumably you'll get an answer in this quadrant, and you'll need to find the solution in this quadrant as well. And once you've found those two values of t, then again you can say how many minutes will it be over. It will just be the time in between those two angles. So it's a case of, when you inverse cos, you'll get that equals an angle and that equals another angle, and then decode it into your two time values, and again do the difference in between them. So once again, I'll let you do the processing on that. Make sure that you're happy moving them around. If you have any questions, if you're not sure about something I went through, if I did something wrong without spotting it, I mean, I almost didn't spot that negative sign, so possible that I've missed other things, then please do let me know in the comments down below. Otherwise, cheerio.